Alright, it's day 2 of the restoration and upgrade of the Sega Master System. I did get a chance yesterday to install the new board here. This is the FM board. And I actually tried it out with Roston, a classic arcade game, which was ported to the Master System. And it's actually really amazing how different the game is just by changing. The music is fantastic, probably as good or better in the arcade version, and then the sampled sound effects are all voices. It's really quite remarkable. I'll take a video of that later just to show the difference. So this board was purchased. All I had to do was install the connectors here and then slot in a board, pull off a capacitor and put it in line and hook up the shield to the circuitry. So I'm starting my work on replacing capacitors. I've only gotten 2 done so far. I try to leave the leads on and clip them when I'm done with all the capacitors. That way I don't accidentally replace a capacitor I've already replaced, because a lot of these caps, I mean, this capacitor here is brand new and this capacitor is almost 30 years old. It's surprisingly hard to tell the difference between them. Luckily on this board, most of the caps are actually blue and the capacitors in this kit are black, but not that it really matters. But you'd be surprised how hard it is to tell. Did you replace the cap? You didn't replace the cap? So just leave the leads on. So it's a good reminder, okay, when you have all the caps replaced, just go through and snip all the leads flush when you're done. So what remains now is replace all these capacitors, which is very exciting. And then I'm also going to install a S-Video out. And S-Video out's nice because composite video smushes together the luma and chroma of video signals. Luma is brightness, chroma is the color. So S-Video splits out the color and the brightness of the signal. So it's a much sharper signal than your standard composite signal, which kind of just mashes it all together into one signal. So that's coming along, and now to get to replacing capacitors. Alright, I wanted to demonstrate, if you ever do capacitor work yourself, how you actually go about removing a capacitor. The essential tools, if you're a masochist, you'll use solder wick, which is this stuff here. And solder wick is, I mean, it works, but basically you hold the solder down, you hold the wick on top of the joint you want to remove, and you wick it off, and it's okay. It's pretty safe to the traces on the board, but you're going to be there all day long pulling capacitors off. The tools I prefer to use are this is a solder removal tool. It has this nice little bulb on here, so when you press it down, pushes the air out, heat up the solder joint, and you let go and it sucks the solder right up into it, and then you go over to your handy non-flammable capacitor and squirt the solder out, molten solder out. You also have your traditional solder sucker. That clunk you heard was the last solder. So it's a nice little, if you got some practice on the board you don't care about, you heat up the solder joint, you hold down on top, and it pulls the solder right out. These boards, I'm kind of hesitant to use this tool on this board because it's an older board. I noticed the trace is kind of lifting off, the pad's lifting off a little bit when I was working on it. So what I did do is I turned down the heat on my soldering iron. If you get a soldering iron, get an adjustable temperature one so you can turn down the temperature, because if the temperature is too high, you can overheat the board, and these are called pads, and these pads will just pop right up off the board and you wrecked a pad. And you could fix it, but you just made more work for yourself. So I did notice even on this old Sega board, this a lot of these solder joints are hand soldered because they're a little sloppy. And you can even see here, I mean, this is a kind of a sloppy joint. It's got way too much solder on the fillet. That's what it's called. It's called a fillet. So here's the cap I want to replace. It's kind of bent over. The lead's a little too long on it. So I'm just going to take my handy little solder sucker, solder removal tool. It's not a nice $700 Heiko solder station or anything like that. It's just a little cheap $30 tool. And really, all you have to do is heat up a solder joint. Kind of get yourself on there. Made a mistake. See? Heat it up. Suck out the solder. Actually, I got most of the solder on that one. And heat this guy up. Get on there. And you can see, it's kind of hard to see, but we'll get a little closer. Most of the solder has been removed from the solder joint, and all I do is take your conventional soldering iron and grab onto the capacitor from the other side. My fingers are on the cap back there, and just heat up the legs, just to let them free. This guy, come on. You want to. Again, I'm just being a little careful because this board is, I mean, it is almost 30. It's just a 29-year-old board, so they do embrittle a little bit over the years. So, capacitor's out. And this is a 47 microfarad 10 volt. So I gotta go on my kit here, find the 47 microfarad. 47 microfarad 10 volt. You'll notice when you get cap kits, don't freak out if the capacitor isn't physically the same size as the cap you're replacing. Because these are actually 47 microfarad 10 volt capacitors. I can see right here's 47 microfarad 10 volt. You see, one is almost half the length, but it's a lot fatter. So don't worry about the size, just worry about the rated capacity. You always want to make sure it's the same capacitance and farads and the voltage, because if you can always go up in replace it with a higher voltage. If you replace it with a lower voltage, the cap will break down. And the other thing you have to be worry about is the polarity. On the board, you'll see there's a little plus symbol on here. That's the positive side. And capacitors, all electrolytics, the stripy side is the negative. So and the positive side also has a longer lead. See, the leads are a different length. Longer leads the positive. Make sure you put the positive in the right spot, negative in the wrong spot. If you hook it up backwards, hydrogen will form in the capacitor, and the capacitor will eventually pop. It'll look like the world's ugliest party favor if you do that. So the actual soldering is very exciting. It's a trifecta of heat, solder, and the material you're working on. Right there. Actually, these solder joints look a little better than the original solder joints, if I don't say so myself. And I did. So, yeah, nice even fillet. These old boards all use lead-based solder. Modern boards use what's known as ROHS, R-O-H-S, reduction of hazardous substances. It started in Europe, but the thing is they took the lead out. I use leaded solder still. I am using, what am I using here? I am using, this is 63% tin and 37% lead clean core solder. So I prefer a nice thin solder. This is leaded solder, so all you have to do is remember to wash your hands afterwards, and don't let your kids play in the workshop. It is lead, but lead gives you a much stronger solder joint. It's much more reliable. You don't have to worry about tin whiskers or dendritic growth. And these boards are designed for leaded solder. This is all leaded solder here. There's probably 2 ounces of lead on this motherboard here, on this board here. So yes, it's lead, it's freaky, but as long as you wash your hands and keep your kids away from it, and when all your solder splashes I keep contained in one spot, it's not a huge issue. So that's how you replace the solder joint, and now I'm off to replace the capacitor, so now I'm off to replacing the rest of the caps on here.